everyone, my name is Olivia Lobeda and I'm from 2F class. And today this video it's about group comparisons, and I'm going to explain about my report that I made by myself about comparing two groups to find the difference of these two classes. Okay. So without any further ado, let's get started. First of all, if you want to test if you want to comparing two classes, you have to find your question research question. I'm sorry. Okay. So my research question is there any means difference in learning motivation between class X and Y? Okay, after you define or make your research questions, you have to make the HO or the hypothesis. Okay, my HO is there is no significant difference in learning motivation between class X and Y. And for the HA is there is a significant difference in learning motivation between class X and Y. Okay. So in this video, I'm just gonna explain my report. So I'm not gonna do the step in SPSS because yes, I'm just gonna report. I'm just gonna explain my report about uh my task. Okay. First of all, to do the test, we have to complete these roles. First one, we have to find the normality test. We have to define the normality test, and the second one is the homogeneity test. Yeah. Okay. As you can see here, this is the descriptive statistics. So you can find this table before the t-test table. Okay, as you can see here, let's analyze this table. First one, let's talk about the mean. These two classes mean they have a different means. In class X, the mean is 55.46, and for the Y class is 53.68. It's only two difference, if I'm not mistaken. So that means the mean from X is higher than mean from class Y. And for the minimum score in learning motivations in class X is 26, while for the class Y is 27. And for the maximum score in learning motivation class for class X is 74, and for the class Y is 81 score. Oh, that's a little bit higher than class X, right? And let's see the standard deviations from class 4. As you can see here, the standard deviation class X for X is 10.114, and for the class Y is 12.25. Oh, that's mean the class Y is higher. The standard deviation class Y is higher than the class X, right? That's mean the distribution of the spread is more variance, because in descriptives in standard deviations, if the highest the scored, the spread is more distributed and more variance, and if the score is lowest, that's mean the spread of the histogram is more not so variance. Yeah, like that. Now let's talk about the first rule. Yeah, that is the test of normality. As you can see here, the table. Yeah, this table is for normality test. Okay, we only focus for the sig or the p side. Okay, here for the Kolmogorov side and Sapirov side. Here. Okay. Learning motivation class X. The P is 0.200 and the class Y is 0.00. Oh, it's same. And for the Sapiro side, class X is 0.441 and class Y is 0.591. Okay, it's a little bit not like this one, right? Okay, let's see for the histogram. As you can see here, the histogram is for the class X. Yeah, X. Okay. As you can see here, this side is more lower than this side, right? That means the tail is start from here. It's a little bit this side, right? That means it's skewed to the left side. We call this pattern is negatively skewed. Even though this histogram is not perfect, it is still a normal histogram. Let's see the class Y. Yeah, even though as you can see here, this a little bit spare in here. Yeah, and let's define the pattern. Oh, yeah, it's more. This side is more lower, right? That means the tail is this table is a little bit skewed to the right side. We call this pattern is positively skewed. Okay, as you can see, it's a little bit it has a little bit spare, but in this histogram, it's still normally distributed. Yeah. If okay, let's see this. This is normally the table. Okay, there is a rule. If you want to check is the data is normal or not. Okay, the rule is if the p is below 0.05, that means the data is not normally distributed. So we have to use the many u. But if the p-value is above 0.05, that means the data is normally distributed. So if the data is normally distributed, we can use the theta's. Okay, let's analyze our normality table. Okay, we have to focus on this sig side between these two, this Kolmogorov and Shapiro side. Okay, for the Kolmogorov side, the P is 0.200. That means it's above the 0.05. It is a normally distributed. That's for Kolmogorov side. Let's see the Shapiro side. Shapiro side. Okay, it's point 0.441 and 0.591. That means it is also above 0.05. That means our data is normally distributed. Okay. After we complete the first rule to use the test, we have to do the test of homogeneity of variance. Okay. In here, we only focus for the best on mean. Learning motivation best on mean because we want to compare the mean, right? Okay. Okay. Here we focus on the mean side, that is P. Okay, 0.150. Okay, that is our p-value. Okay, let's see the rule for the homogeneity of variance. That is the rule. If the p is above zero, below, sorry, if the p is below 0.05, that means the variance between the two groups are not equal. So what we have to do is we have to use the equal variance, not assume in theta. And if the p-value is above 0.05, that means the variance between the two groups are equal. So in this situation, we can use the equal variance assumed in t-test for our analysis, our hypothesis test. Okay, let's see our p-value here. It's 0.150. That means our p-value is above 0.05. That means we can use the equal variance assume because the variance between the two groups are equal, right? So if you already done the two rules to use the test, you can test your hypothesis. So to use this hypothesis to use this t-test, you have to done this two rules. That the first one is the normality of that the normality distribution, and the last one is the test of homogeneity of variance. Yeah, if the data is not normal, you can use the test. Why? Because that is the rule. You have to use the man whiny you, so you cannot use the t-test. So make sure you analyze your data normality table. Yeah, you have to try to look the p-value. Okay, if the data is normal, that's you can use the t-test. Okay, that is the two rules if you want to use t-test. Okay, now because my data is normally distributed and the homogeneity is equal, so I can use t-test, and I can use the equal variance assume in my t-test for test my hypothesis. Okay, so if you want to check the hypothesis, you will find these two groups. Yeah, the two tables. I'm sorry. The first one is group of statistics. This is, as you can see here, you can see the mean between class X and Y. Mean class X is 55.4946, sorry, and for the class Y is 53.69. So this is a difference, right? There is a difference between this mean of these two classes. Yeah, there is a difference, but in this case we want to figure out, is it the difference is significant or not? That is we want to test. Okay, we want to find it out if this difference it is significant or not significant. That's it. That's what we want to test. Okay, there is it. Okay, here you can see here the table independent sample test. Okay, because our test homogeneity is equal, we can use the equal variance assumed in the test. So in this table, we only see from here side. Learning motivation equal variances assume. Okay. In here, we only focus for the significancy side. Yeah. here. It is 0.191 and 0.3381. Okay, that is our p-value in this equivariant issue, right? So in this tables, in this t-test, we also have the rules. Okay, here's the rule. If the p is if the p is below 0.05, that's mean the t-test is finally can reject the HO. And then so we are confident that our H is correct. But if the p-value is above 0.05, that means the t-test is fails to reject the HO. So yeah, we are not confident that DH is right. We are supposed to trust or to believe to DH. Okay. We have to look the our previous HO. That is, there is no significant difference in learning motivation between classes X and Y. Right. So in this HO, our hypothesis, there is no, right? There is no significant difference. Okay, that's what we want to check. Okay, let's check it. Let's see for the significance side. Yeah, as you can see here is 0.191 and 0.381. That's mean our p-value is above 0.05. Okay, that's mean this uh these tables conclude that there is no significant difference in learning motivation between class and Y. Yes, why? Because the p-value in this side is higher than 0.05. That means the test is failed to reject our HO, and we are not confident that HA is right. So we have to believe. You have to believe to the HO that we already made. Okay, and here my hypothesis my HO hypothesis is there is no significant difference in learning motivation between class X and Y. So the conclusion is there is no significant difference in learning motivation between class X and Y. That is my conclusion. Okay. Yeah. Okay. Maybe just that I can explain about my report. I'm so sorry. I can show how I do my how I do this step because my expenses is already uh expired. No, yeah, it's already expired, so I can share screen. How do I work in SPSS? Yeah, but this is the report that I made by myself. I'm not using any kind of AI. So yeah, that is for me. Uh, thank you very much for the times. I hope you guys can understand about group comparison.